So software is available in the Teams. You can go to the file section and see the LiDAR Lab folder. In the LiDAR Lab folder, you can see there is a folder named Limulator 2.0. You need to download that. And if Java is not installed in your PC, then you need to download JDK, Java software also. And you need to download Java 3D also. I have selected here. So you please first download the Limulator, and then if Java is not in your PC, then you can download Java from this folder also. Follow these steps, please. Then I will tell you further how to install this software.
Sir, what is size of these software, all the three, sir?
This software is very small software, just 1 MB or 2 MB.
Okay, sir.
And Java size will be approximately 150 MB. So you first download Java and install in your PC. After Java installation, you can go to the bin folder of Java and paste all the folders in the Limulator 2.0. Let me show you. Suppose you have downloaded this. I have already installed the Java, and now I need to install the Limulator. So now extract the files from this zip folder. You can see there are 3 files, 2 folders, and one application. You need to copy all files and paste it to the bin of Java. Go to the Java and then go to the JDK, and in the bin folder you need to paste, because I have already placed file here, so it will ask for replace. Now you need to access the simulator from this bin folder only. If you try to open this software from directly from the folder, then it will not open. So you need to go to the bin and then click on simulator. And this type of interface will appear. And now please confirm if you completed these steps. If you are facing any difficulty, you can discuss with me.
Hello, sir.
Yes, Alok.
अरुण।
Okay, Arun.
सर मैंने वो दोनों जावा फाइल तो इंस्टॉल कर ली सर, उसके बाद क्या करना है स्टेप वो बता दीजिए।
Okay. So if you have installed Java, then you can go to the Limulator folder and copy all these three files, and now go to the Java in the program files. So Java installation folder, if you go to the Java installation folder, then go to the JDK and paste all these three files in the bin of this JDK. Okay.
थैंक यू सर।
Now, if you want to access that software, then you need to open the software from bin folder only. If you try to open outside from outside of the bin, then it will show some error. It will show error like Java has not found in your computer. So if you want to avoid this error, then you need to open this simulator from the bin of Java. So this type of interface will appear if you open the simulator. Now everyone please confirm that you have installed the simulator in your PC. Please confirm so that we can do the experiment.
सर हो गया.
Yes, sir,
Okay.
installed.
Okay. So you can see this type of interface here, and it is written like airborne altimetric LiDAR simulator. So it will generate a LiDAR data with the specified flight planning, sensor type, errors, etc. And we can generate the complex surfaces from this data and simple surfaces also. So this data will be very much accurate so that you can test your algorithm with this data, and you can introduce the errors in the data to see the effect of errors in the data. So this is a true form of data that can be used for the testing of algorithms. Suppose you develop an algorithm and you want to test the efficiency of that algorithm, then you can use this data, that data generated from this LiDAR simulator. So to generate the data from this simulator, you need to follow all these steps. So first step is go to the surface and first select the area extent. So you can select the default area also, and you can define the area extent by yourself. So I am taking it default. After that, you can select a mathematical surface. This is the equation for the mathematical surface. This is the equation of plane. So you can define the, you can select the values of constant in this equation, and you can select the complex surface also, and also the combination of simple and complex surfaces. So I am selecting the simple surface and coefficient values are 0, 0, 1. Click OK. Now I am selecting a rectangular box. Then this area is selected and click OK now. Now minimize this. Then go to the city model and click on draw area. Then you need to draw some area. For that, you want to generate a LiDAR data. Then you can select some 3D objects in the data. Suppose you want to insert a rectangular box, then you need to provide parameters for the rectangular box. Then you can insert the cylindrical like object, and you need to provide height for the cylinder, and many more objects you can add. After that, you can generate the raster. So raster file will be generated for this surface. Means you need not to skip any of these steps. So I am writing the name as name of the file as lab2. So it is generating a raster data file. After that, you can read the raster file. So the file name was lab2 raster. Now it is reading the raster data file. One area file is also generated, and you can read that file also. After that, you can minimize, and then you can also generate the fractal file. So for that, you need to generate a area. You need to select an area for the fractal surface generator. Write the name of fractal file. So I am writing file name as 2, lab2, and it will generate a fractal file. Now click OK. And minimize this also. Now in the flight parameters, you can define the different parameters. Suppose you want simulated acceleration, or you want no acceleration. Suppose you want to simulate data without the acceleration, then select without acceleration and click OK. Now there are 3 types of sensors can be selected. So I am selecting a generic sensor, and you can define the AGL, above ground level, and what percent of overlap you want in the data, and the velocity. And you can select also the scanning pattern. Suppose you want sinusoidal scanning pattern, then you can define the frequency of the sinusoidal pattern. So I am selecting the default values. Now click OK. Now minimize this also, and you can also define the roll pitch of components of the data. Suppose you want simulated roll pitch here, then you can select simulated roll pitch here, and then suppose you don't want any movement in the vehicle, then you can select as without RPY. Now you can introduce the error in the data, error in XYZ values. So I am selecting here without any error. Now you can generate the output. This is the main part. Here you can see different kinds of output you can obtain. So based on your selection, the output will be generated. Suppose you want only last file, want to generate only last file, then select that last file only. And I am selecting all the outputs and this report also. and it will ask for the name of the file. So I am writing name of the file as lab_2. So the last file will be generated, and that can be visualized in the Cloud Compare software or any other 3D visualization software. So now you need to follow all these steps and generate the output. Yes.
सर मैंने जावा की दोनों फाइल इंस्टॉल कर ली है, उसके बाद भी जब लिमिनेटर इंस्टॉल कर रहे हैं तो बोल रहा है कि जावा डाउनलोड करने के लिए।
You need to open simulator from that bin folder only.
Sir, which folder? Where is that?
If you go to the program files of your go to the installation folder of Java. Okay.
Okay,
There
sir.
is a bin folder. Let me show you. You have installed Java in your PC, right?
Yes, sir.
Then you can go to the installation directory. In the program files, it may have Java folder, or in the program files, anyone may have that Java folder. Now go to the Java folder and go to the Java JDK folder. now, and here you have bin folder. If you have pasted all 3 files in the bin folder, then you need to select this simulator. If you
Means
try to
we have to paste all those 3 files over here, sir.
yes, you need to paste, and if you want to start again, then you need to start from here. You just click on this simulator and it will be open.
And sir, anytime whenever we want to start it, we have to start it from here only.
Yes.
Okay. Sir,
Yes.
sir, in flight plan one tab, sir, we have to select rectangular. Then directly we have to click on OK, or we do have to do anything else.
You can do anything, but you have to click OK. If you want to draw your own surface.
Yes, sir. Sir, after selecting rectangular box, I am doing OK, but it is this window box is not vanishing. It is not going.
Okay, simulator is like that. You if you click OK, it is selected. Okay.
Okay, means I have to just minimize it. It will not go.
You can directly go to the next step from the menus option, or you can select from the GUI.
Okay, means sir, it I have to just minimize it, isn't it?
Yes, just minimize, then go to the next step.
Okay, sir. Sir,
Yes, Sumit.
सर ये हो गया है, 8-10 फाइल बनी है सर इसमें।
So there is any file with the extension LAS
AS? Yes
last?
sir. Yes sir. LAS. Yes.
Okay. Can you
Two
open it in
two
the?
files are there.
Okay. Now open that file in the Cloud Compare and show it to me.
Sir, Cloud Compare software is not working on me. Sir, I'm showing you my. I'm sharing my screen.
Okay. Okay. Share.
Sir, is it visible? Sir, is it visible?
Yes, it is visible.
Sir,
Okay.
these files are there, and sir, this Cloud Compare software is saying this type of error, sir.
Okay. Do you have setup for that?
So Cloud Compare.
Yes.
Sir,
Try
let
to
me check.
install again.
Sir, what is the size of that Cloud Compare software, sir?
Just 300 MB. 100 MB. Sorry. It's 100 MB.
Sir, is it there in Teams?
Yes, in the Teams.
Okay, sir. Then, sir, I'm sharing it after installing, sir.
No, there is one extension you need to that plugin. You need to select that also. So if you are trying to if you are installing, then show it me how you are installing. Okay.
Okay, sir.
Yes, this only.
Sir,
Yes, Alok.
sir, I have completed all the process, but only two files are generated, sir.
Okay, you are not able to generate the output.
Yes, sir.
So the concept is to do not skip any of these steps. Okay. Follow from the sequence.
What, sir?
Try again. I think you have missed any of these steps. That's why output is not generated. So try it again and do not skip any of these steps.
Okay, sir.
Okay, sir.
Sir,
Yes.
सर
Yes,
मैंने
Arun.
सिर्फ सर मैंने दोनों लास्ट फाइल को क्लाउड में ओपन करा है, तो सर ये ब्लू रंग का रेक्टेंगल आया, उसमें लाइनिंग है सर।
Okay, share your screen.
सर वेट। Sir, is it visible to you?
Yes, yes. This is your LiDAR data. Okay, this is generated LiDAR data. Okay. Now take the screenshot of all these steps and it will be pasted in your lab record file. Okay.
Sir, screenshot of.
Because this is okay, let me finish. That this is your simple surface. If you try to generate a complex surface, then some type of undulation will appear in this data.
So, सर आपने जो स्क्रीनशॉट बोला है, तो जो सिमुलेटर के सारे मतलब सरफेस सिटी मॉडल इन सब के स्क्रीनशॉट ना सर?
Yes, yes, all the steps and then output.
अच्छा सर, ये हमने जो सिमुलेटर में जितने भी स्टेप करे हैं सर, बट इसका सर मुझे मतलब कि सिग्निफिकेंस समझ में नहीं आ रहा सर। हमने तो सब कर दिया, बट ऐसे ही वैल्यू डाल के सर, बट समझ में नहीं आ रहा कि हमने किया क्या है।
Okay, see that we in the first experiment we collected the data from the field using the laser scanner. Okay, ferro laser scanner, and we have seen that data, the type of data acquired in the scene software. Okay, and then this is the LiDAR generator. We do not have any scanner here. Okay, we are generating data just by writing a code. So because data collection is very costly procedure. Okay, so if you are generating data in the laboratory of specified requirement, then you are saving so much of cost because you are generating LiDAR data in the laboratory, and that data can be used for different purpose, like the students can be made aware that this kind of true data we can get, and you can implement different algorithms on this data. This is ideal data. Okay, and the data you are collecting from the field, that is some practical type of data. So for algorithm testing, this data is the best. Okay, and you can introduce the errors in the data. Suppose you want acceleration in the vehicle that is collecting this data, then you can introduce the acceleration speed of the vehicle, etc. If you want to add some kind of noise in the data, you can add and see the effect of the noise in the data. So that's why we are, and you can also write a code to separate the ground points from non-ground points and test that algorithm in this data. And you can add 3D objects in the data. Okay, so if you add 3D objects, and they will appear as a point cloud in the data. So this is the significance.
Yeah, Mukesh, Arun, thanks. This, you have explained many points, Mukesh. So few points also I would like to add over here. See, this Limulator is the software that talks about entire process of data acquisition. Okay. We have been discussing in case of airborne LiDAR. So if you see that the LiDAR system, if it is operate, this laser scanning we perform through mobile platform. In that case, the LiDAR system is comprised of laser scanner, that is 2D scanner, as well as positioning and orientation system. Okay, we'll learn it later on how the data collected by individual sensors are combined together. So what is happening? Like assume Earth as a mathematical surface. Okay, digital surface model DSM, it indicates like we have a ground as well as on ground object. Like if you see from top the Earth surface, so the entire object, like there is a rooftop, there are trees, ground points, roads, etc. Okay, so the mathematical surface that represent this ground terrain, we call it DSM, digital surface model. So what actually this simulator does, it simulate the process, the functionality of individual sensors like laser scanner, positioning and orientation system. So if you see what happens, like in a 3D space, a unknown point coordinate we compute in a global coordinate system. Okay, so there are few coordinate systems which are defined with respect to the individual sensors. Like we in positioning and orientation system, we have GPS and IMU. With respect to GPS, we define one coordinate system. With respect to IMU, we define a coordinate system. And we have a coordinate system defined with respect to laser scanner unit. Now laser scanner does measurement in its own coordinate system. IMU plus GPS computes trajectory of moving platform. And finally, by combining trajectory of moving platform and laser scanner data, what we do, we calculate a unknown point coordinate in a ECEF, that is globally defined coordinate system, in which GPS does the measurement. So if you see that Limulator, what we do, we know the equation of mathematical surface. It is defined like what you have doing. You are selecting different shapes in this software. That the selection of shapes means you are defining a mathematical surface. It is known. Okay, then you are selecting certain parameters for your LiDAR system. Then let's say if you have a known mathematical surface and you trace a ray, like there is a LiDAR system, that LiDAR system fires a beam in a straight line, it intersects that mathematical surface somewhere. That point coordinate you measure in the globally defined coordinate system. So mathematical surface is intersected by a laser beam, and that line equation is known. Okay, so that intersection coordinate is calculated. It is coded like that. Once again, I will take up this entire problem when we will discuss about geolocation equation. I think after few lectures we will be there to discuss this concept. So we'll it's unit third. Okay, so there I will take up the concept of Limulator and the mathematical steps which we have for integrating the data sets collected by individual sensors. Data set of LiDAR laser scanner in its own coordinate system, data set collected by IMU and GPS that gives a trajectory, how that aircraft is moving. And finally, in the Limulator context, we define that we know this mathematical surface. Okay, so it's a kind of problem like a line equation is given, you know the surface equation, and at a different point we have a series of lines, they are intersecting. So if equations, mathematical surface equation, line equation is given, you can derive this where it is intersecting. That coordinate can be computed. Okay, and meaning is to understand like entire process. Like for you, you know the when we discussed, okay, these are the steps. by using the software itself, what we do, it helps us to select the parameters like flight planning, like we are discussing right now. Okay, in the flight planning, we have derived the line densities, two equations we have derived. Okay, and that is entire the theoretical analysis. But Limulator gives you idea, okay, these are the points. If you select these parameters, you can generate the simulated point cloud, and there you can check it, okay, how much point density we are getting along the line, scale line, and across the scale line. Even further, as summarized by Mukesh, like if you a laser scanner has any laser scanner, 2D laser scanner instrument has its own error. If you increase the error or decrease the error, then how finally it is propagated to the final coordinate, that estimation also can be done. So let's say uh, uh, in your project, the requirement is the vertical and horizontal error should be less than 10 centimeter. For your project requirement, you can't bear error more than 10 centimeter. Okay, so this Limulator gives you idea about, okay, without any error, what is the data. Okay, but when you add error to the individual component, let's say you have selected a set of component, a particular company make and model, GPS unit, IMU unit, and 2D laser scanner unit, and you know the calibration process. Okay, now you know, once you decide the make and model of the different sensors, in their specification sheet, you can get the how much error is generated. Okay, what is the error? Once you put that error in your Limulator, this simulator, this error will finally propagated to the coordinate. So without error coordinate, you know, with error you know the coordinate, you can see, you can calculate the RMSE, and then you can analyze whether it is within 10 centimeter bracket or it is outside more than 10 centimeter. So that gives you idea to select the sensors. So it is very helpful for the companies. Okay, let's say there is a project. In that project, the requirement, it should be less than 10 centimeter. So how they select which LiDAR system they have to install, which LiDAR, using which LiDAR system they need to go with laser scanning. So using this Limulator, it can be quantified. Is it fine, Arun?
Yes, sir. Thank you so much, sir.
You're welcome. Is there any query? Okay, fine. Mukesh, please go ahead with your discussion.
Thank you, sir.
Sir, I have downloaded the Cloud Compare. Sir, I'm sharing my screen. Please see the installation process.
Okay, okay.
Sir, this I have to install.
Yes. check this plugin also.
Yes, sir. Sir, now what to do, sir? That result part?
Drag and drop that last file, that last file
Sir,
generated
which one?
with LAS extension.
Sir, two files are there, 10 and 11.
Anyone? Just one file with the last format.
Yes, sir. Sir, apply.
Yes, apply all. Okay, this kind of data you will get if you take a complex surface, then some type of undulation will appear in the data.
Okay, sir.
Okay.
Sir, what about all other files? These.
These are the XYZ files, and means you can see those files, what values are present in the data, and raster file. So here you are getting XYZ. Okay.
Okay, sir.
So there are
These coordinate values are these, sir.
this is the location information of all these points. You have 3D point cloud, right? And now
Yes.
you have the position of each and every point of the point cloud.
Okay, sir. And sir, what about these two files where we can open it, and what are these, sir?
For that, you can use TerraScan software. If you have generated a fractal surface, then that file can also be open in the TerraScan. And for more information, you can open the software help section.
So what, sir?
You go to the software, that Limulator, and open the help section. Here it is mentioned that you can open all those files in the different software. So if you open these files in TerraScan, Surfer, etc., you can open those files like raster files, fractal surface model. You can open in the TerraScan also. You can also go to the IIT Kanpur page of this Limulator. Let me show you. So these kind of outputs you can obtain in the simulator. So this is the raster terrain. It is visualized in the surfer software. And this kind of fractal terrain you can visualize in the surfer also. And this you can see the effect of errors in the data. Here it is mentioned that data without the error and with the error.
Sir,
Yes, Alok.
sir, is this correct?
Yes, correct. No issue. If you zoom in this surface, then you will see the point.
Okay, sir.
Hello, sir.
Yes, Sunil.
Please be my.
Yes, this kind of complex surface, I think. Good. Good, Sunil. Okay. Keep the screenshot for your lab record.
सर
Yes, Tarun.
सर वो जो आईआईटी कानपुर वाले आपने जो लिंक था ना सर उसको चैट बॉक्स में सर पेस्ट कर दीजिए
Okay.
Sir,
Yes, Bhagat.
sir, I also completed task.
Sorry.
I also completed practical. So,
Okay. Okay. Show your screen. Share your screen.
yes, sir. So there are two .ls files.
Okay. Because in the output section, it is show you have selected two types of LAS, na? That is LAS 1.1 and 1.2.
Yes, sir.
That's why two types of outputs are generated. So
Okay.
you can keep the screenshot of this output for your lab record.
Okay, sir.
In the lab record, all the steps should also be mentioned with the screenshot. Okay.
Okay, sir.
Sir, how to prepare report for biggest practical, sir? Sir, have you shared the objectives in the team, sir?
I am sharing the syllabus and the objective for first two experiments. Okay,
Okay,
you
sir.
need to complete first two experiments by next lab. Okay.
Sir, first one was that LiDAR data input one, that one.
I have shared the syllabus. Let me share again. Okay.
Okay, sir.
So I have shared laboratory as well as theory syllabus in the meeting chat. And first five experiments are LiDAR lab, are for LiDAR lab. So you need to complete first two experiments by the next lab.
Sir? Oh, sir.
Yes, hello.
Can we leave now?
No, it's 10:30. Okay, lab is up to 11 a.m. If you have any query, you can ask. Otherwise, you can start writing your experiments.